So far we've talked about truth tables and how you can completely specify a Boolean function with a truth table. It's also possible to, once you have the truth table, to go in reverse and write down a Boolean expression. It's particularly easy with canonical forms like sum of products and product of sums. So because of this, and because truth tables are useful, it's also useful to have a compact notation so that we can represent the information from truth tables in various forms. Okay, so what I wanted to talk about in this video is the idea of minterms and maxterms. These will make more sense when we get to Karnaugh maps, and you'll see that a minterm is the minimum space on a Karnaugh map, and a maxterm is the maximum space on a Karnaugh map for a POS form. So before we get to that, though, let's talk about minterms and maxterms. So this graphic is useful because you can specify the output of this 3-variable truth table. So we're restricting our attention to just 3 variables. The concept generalizes to more variables. All right, so what I can do here, if I click this 1, you'll see that the canonical SOP form starts to show up. So if I click the one showing up in the 0, 0, 0 row of the truth table, the corresponding variable names would be A bar, B bar, C bar, okay? Because you take the complements, you get, basically the complements represent zeros, and uncomplimented versions of the variables represent ones, okay? So that's showing up in as the canonical SOP. If I add another one, okay, now I get A bar, BC, all right, A bar BC for minterm 3. So the minterms are just the binary numbering coming down the rows of the truth table. And we can have the canonical form with the variable names showing up as we add in the ones in the truth table. Okay, so for each minterm, exactly one row of the truth table shows up. So if I wanted to add minterm 7, that would be A, B, C. All right, so when I'm done, if this was the truth table that I wanted to represent with this Boolean function f, then one canonical form would be this Boolean expression. But it's a pain to write this out, and so what we do is we assume a hierarchy of variables. So the A variable here is in the most significant bit position. That's how the numbering goes with the minterms. All right, C is the least significant bit. And so then we can just list the row numbers that represent the truth table. All right, so this would be a minterm list that represents this canonical form. And then later on, we'll see with Karnaugh maps, you can actually represent this function with fewer logical connectors. All right, so that would mean that you could implement it with a smaller circuit. Okay, so corresponding to the idea of a minterm is also a maxterm. So minterms are naturally associated with sum of products because as you add product terms, the minterms show up in this list. Maxterms look like this. Okay, so let me clear all these back to ones. All right, so there's a dual here. For minterms, you're mapping where the ones go. For maxterms, you're mapping where the zeros go. So let's pick on a row here. Let's click this one. All right, so this is the canonical POS form for F. All right, so this is row 2. All right, so if you think of this, this would be 1, 0, 1. If you complement that to 0, 1, 0, you get back the number 2. All right, so there's this complementing that goes on with POS, which makes it a little harder and less natural to think about. But this is the canonical form for product of minterm 2. All right, so I could add more terms here. I get additional products. And then what happens is, later on we'll look at these with Karnaugh maps, with product of sums, we're looking at these intersections of maxterms. All right, when you AND things together, you get intersections. When you OR things together, you get unions. All right, so there's a duality here. I wanted to make sure you understand both minterm lists and maxterm lists. Okay, so I can add another variable here. It'd be 2, 4, 7. This is the canonical POS. And I can flip over here. I can have the exact same truth table. That's the way this graphic is set up. It turns out 247 as a product of max terms is the sum of minterms 0, 1, 3, 5, 6. So you notice what's happening here. Everything that's missing from the count shows up in the minterm list. All right, so if I flip over here, I get the same representation, 0, 1, 3, 5, 6 as canonical SOP. All right, so we can go back and forth between these dual forms. It's more natural to think of SOP, so that tends to be where we focus. All right, and so I wanted you to be able to take a truth table and represent it as a minterm list and understand what that means in terms of a Boolean expression. So for example, if I had a truth table with just 4 and 6, this would be F equals A, B bar, C bar. That's corresponding to minterm 4. And this would be A, B, C bar, corresponding to minterm 6. As you see here, I have the minterm list. If I wanted to convert that to a maxterm list, it would just be all the terms that don't show up over here. So 4 and 6 show up over here, so the rest would be 0, 1, 2, 3, 5, and 7. All right, so that's the basics of minterms and maxterms. It's an important vocabulary term. We'll be using these terms throughout the rest of the course.